Thanks, Peter, for that introduction. That was awesome. And before I even start, the two previous keynotes were awesome. I was so excited. I love Karen's talk about. Is she in the room today? Karen here? She had to head out. That's too bad. I loved her talk. It was so good. So on to mine. Today, well, maybe I'll give you a background about who I am. So I'm Cameron Davidson-Pilon. I'm the author of Bayesian Methods for Hackers. As Peter was saying, it's an open source book to teach Bayesian methods to non-mathematicians, people who don't have a background in math. There is a print version available as well. It just came out a few weeks ago by Addison Wesley. You can get it on Amazon. Unrelated, it's important to support local Canadian authors. I'm also a data lead at Shopify, a little plug for Shopify. So the core app is Ruby, but the data team works exclusively in Python. We do Spark stuff, really cool technology. It's a really great stack, great team. And you can find me at Cameron Davidson-Pilon, or CamDP at Twitter. So what does this talk about? What did I mean? I guess I should introduce the title of my talk. It's reversing the Python data analysis lens back onto ourselves. So this talk is about, we've seen Python, the past 2 days, in fact, we've seen Python data tools really evolve and be showcased. We have Python tools like pandas, numpy, scipy, beautiful soup, requests, all the database libraries. Python's great for organizing, collecting, and analyzing that data. But what we haven't done, and also the data sets could be bioinformatics. We saw yesterday financial data sets. We saw protein structures, robotics data sets, some really cool stuff. One data set we haven't looked at is Python itself, our source code, our developing habits. We haven't looked at software as a craft through the data analysis lens. So what are some examples of this? What do I mean? Let's try to settle the 2-space versus 4-space indent controversy. Let's topic model Python source codes using LDA. We can answer what is the most controversial Python answer on Stack Overflow. We're going to data mine requirement.txt files, looking for co-occurrences. Is flat really better than nested? That's a Zen of Python. We're going to try to answer that today. And if you want, you can follow along on at this URL. I actually recommend it because I'm going to skim over a bunch of the analysis and some of the results. I saw a bunch of laptops just flip open. Check it out. It's just like a GitHub repo of all my analysis, plus like a nice README summary of what I'm going to talk about. So I want to talk about Walmart in the 1990s and 1980s and basket analysis. So Walmart had this is pre-high-tech, pre-internet. Walmart had very little data. Well, they had lots of data, but in very particular places. They had lots and lots of receipts. And these receipts were essentially baskets. They knew items within each basket that shoppers had. And Walmart wanted to know what are interesting co-occurrences of items inside those baskets. And they could do really cool things with this. They could discount one, upsell the other. They could put the two items on the shelf beside each other. They could very sinisterly put one item on one side of the store and the other item on the other side of the store, so the shopper has to go through all the different aisles. I mean, you see this today with grocery stores. They put milk on one side and bread on the other, or vegetables on the other. So they want to do this stuff. And it's an interesting problem. If you have n items in your store, the complexity, or the number of pairs is about n squared. That seems whatever, no big deal. But if you have thousands of items, immediately you have about 1 million pairs you have to go through. So it's actually quite interesting, complex problem. And I think it's every developer's dream to implement the solution to this problem. It's called the a priori algorithm. It's a really nice algorithm, works really well. It's pretty fast. And it cuts through this massive n squared space and finds the interesting co-occurrences. I also want some guarantee of significance, and a priori gives me that. I don't just want, this happened once, therefore it happened, or therefore it's co-occurrence. I want some degree of significance. So why am I talking about like Walmart and basket analysis, even though it's a really cool problem and it's very applicable today? Let's try to mine co-occurrences in our requirement.txt files. So GitHub has all the requirement.txt files that you can imagine. So what I did is I scraped all those, and what you might get is a data set that looks like this. You'll have like library 1. Notice that has matplotlib, numpy, scipy, lifelines. Library 2 has Django, psychopg2. Library 3 also has that. Library 4 doesn't have psychopg2, but just Django. And so you might sort of just intuitively as well, you might say, yeah, if my project has Django, it probably also has psychopg2. And so what I did is I took all these requirement.txt files, mined them, and I threw it through this a priori algorithm. I essentially applied basket analysis to requirement.txt files. And what we get is data that looks like this. So if I have Django in my requirement.txt file, the probability of me having psychopg2 is about 40%. And you can read it that way. It's a conditional probability. So given I have the Django, what's the probability of me having this other library? And that's really cool. That's neat. That's fun. Like, OK, cute. What can you do with this? What are some like immediate applications? One thing that you might want to do, or one thing that maybe the PyPI authors might want to do, is have really cool recommendations on PyPI. So you could say, people who installed this also installed, and give recommendations. I actually don't, like, that's a terrible suggestion. We shouldn't do that. I mean, I don't think this will ever be implemented, but it could be like really cute and whatever. Maybe an April Fool's joke. If the browser's too non-developer for you, you could also use what I created. It's called pip. And one of the P stands for personalize, but basically get annoying recommendations after you pip install. So you can pip install pip and do a little demo. If I can. There we are. OK. Great. So if I do pip install, and let's say jsmin, everything works great, and then it gives you a nice recommendation. So people installed jsmin, also installed cssmin. So let's install that next. Anyways, you sort of get the idea. Great. So we have these relationships between libraries now. I can say with some probability or some confidence that this library is connected to this library, which is connected to this library, and connected to this one and this one. And you can sort of see where this is going. You can create like a network of libraries based on this data, these relationships that we mined. So what might that look like? If I take all the data, all the libraries, if I threw them onto a 2D plane and sort of let the strength of the relationship sort of bounce them back and forth towards each other, it's called like a force-directed network. And actually, network X, the Python library, implements this very well. What might that look like? And this is not a high-res image. But these are all, like each node is a Python library, and the lines are a relationship between those two. And you can sort of see things clustered together. I'll go into more detail in a second. If you were to that URL, you can see this in high res, but I'll give some examples. So this is the island of data analysis. You see Seaborn, Matplotlib, SciPy, NumPy, scikit-learn, pandas. So that's really cool that we sort of found that in this network visualization. This is the island of annoying your friends with PEP8. McCabe was interesting. I never knew about McCabe. There's a library called McCabe, and it measures the code complexity of your code. I had no idea about it, but it's cool to see it like inside this sort of Flake8, PEP8 sort of island. This is the Celery Peninsula. These are all other libraries that go well with Celery. I've actually never used Celery, so this was interesting to see. The Django ecosystem. There was a talk yesterday about Django and Flask. And the presenter used the word Django ecosystem, so I wanted to showcase that. And you can see the massive number of libraries that surround Django. And there's psychopg2 sort of squished right beside it, and that's pretty interesting because of that strong relationship. And then, yeah, this is the URL. If you want to check out more, the high-res version, you can see it there. So I often hear that the plural of anecdote is not data. And I do actually disagree with that. I think the plural of anecdote is data. So long as you can really quickly back that up with thousands of other examples, then yeah, you have data. So how often might you see this inside code? You might see stackoverflow.com links inside code. I've done it myself. Maybe one of you have done it. You might be reading source code, and this comes up, and you might check it out, whatever. And it happens again. And OK, that's cool. That's two anecdotes. Happened to a friend of mine. Is that actually data? Can we prove that there's a data set behind this? And using, I think, the most underrated data analysis tool ever, the search engine, you can quickly discover, yeah, this is actually data. So if you search GitHub for this, you can see there's about 75,000 links that have, 75,000 repos that have a Stack Overflow link. One second. Thank you. Whew. OK, so similar to the requirement.txt problem, I scraped all this data. And let me just say that scraping is the most fun activity. I just love scraping. It feels like cheating. I'm just collecting this data really quickly. And the combination of like requests and beautiful soup gets you so far when you scrape data. This isn't exposed through their GitHub API, so it's really scraping search pages. So these, so I scraped all that data, collected them, the top 10 occurrences, and what do we get? These are the most common Stack Overflow questions inside Python projects. Now, this is actually pretty interesting. These questions sort of reveal what are Python programmers and developers getting stuck on. Where do they need references? Where is our documentation lacking in these projects? So maybe I'll quickly just go to one of these, and we can see what they're mentioning. So this one's interesting. This is the most common Stack Overflow question in Python repos, and it has like no upvotes or downvotes. Like it's a pretty, specific question about hiding attributes on a folder in Windows. Like, so what's going on there? Why is that actually the most common Stack Overflow question in Python repos? You go to GitHub and just search for that. You see code. That's mine. So we can see it's always in this Windows support.py file. So what's going on there? We can see, there's the Stack Overflow question. Looking at the path, though, it's inside, this Stack Overflow question is inside the Python 2.7 source code base. And in fact, people are including the entire Python source code base inside their repos. So this is why it's the most common thing, which is interesting. So even the best Python developers, once you work on source code, still need to reference Stack Overflow. So no shame in that. Let's do one more, just to get a different flavor. And this is a common problem that I encounter all the time, importing a module from relative path. Is it 2 dots, 1 dot? I have no idea. So that's interesting that we have this sort of data-driven document, or like what documentation is lacking. All right. So speaking of Stack Overflow is amazing. We can try to answer next, what is the most controversial Python answer on Stack Overflow? And to do this, we have to first realize the amazing thing that Stack Overflow did. They exposed all their API, or all their data, all their upvotes, downvotes, answers, questions, links, stuff like that. And you can see that here. This is the URL is data.stackexchange.com. And these are just queries. You can execute queries against their it's probably like their database, their data database. And you can do whatever you want. So what I did, and this is like the best, like companies should try to achieve this sort of transparency and data collection. So what I did is I wrote just a SQL string, a very complex SQL statement. And what this SQL statement is trying to do, it's trying to balance between two things. So the first is we need to define what is controversy. What's a controversial question? It's probably where the upvote downvote ratio is about 0.5. So the number of upvotes divided by total number of votes is about 0.5. That's a good definition of controversy. Secondly, I need to balance how much data I have. If I have like 1 upvote and 1 downvote, sure, the ratio is 0.5, but I'm not very confident that it's 0.5. There's too little data. So what this is basically trying to do, it's trying to balance how close am I to 0.5, the upvote downvote ratio to 0.5, and how much data do I have. Those are two opposing things. I try to balance those. So if you run this query, this is the result. The closer score is to 0, the better. So what we're looking at is the most controversial Python answers. So let's take a look at one of these. So the question is, does Python have private variables in classes? And the most controversial answer, and it's just this rant about Java and Python. And you can just immediately, if you've seen Stack Overflow, and all of you have, you can just see, just from the comments, this is a controversial answer. -1, +1's, like so many upvotes on these comments. And I just love this ending, like calling out like a sociopath inside an answer. Anyways, what's interesting is that this is not like the most downvoted answer. This is like a controversial, which means people are actually upvoting this still. So it's pretty interesting. Let's look at another one. I think this works. Cool. This is just about the differences between Perl, Python, awk, and sed. It's been closed as well, which is hilarious. And this is the controversial question or answer that I believe. And again, just like lots of comments about, can't do this, can't do that. Anyways, so it's interesting. Simple SQL query, execute against their massive database, and you get these really interesting things. Okay. And so you can explore more of this on this URL. Just check it out, and you can see all the rest of the list and how I did the query and all that. Cool. So Python debates. Let's stop arguing on the internet and start looking at the data. Let's look at what developers actually do inside their libraries. So for this project, or for this part of the presentation, what I did is I downloaded, I think like 36,000 GitHub and PyPI repos and libraries, and I just stored them onto a server. And I just let scripts just run over them and calculate stats about them. So the first thing we'll answer is 2-space or 4-space indents. So who does 2 spaces here? Some shy hands. Wow. Oh, someone went like this. Okay, so who does not 2 or 4 space? Interesting. What do you do?
You're supposed to use tabs for indentation and spaces for alignment.
Oh, okay. So interesting answer. Okay. I think I treated tabs as 4 spaces in this. Maybe actually. I did. Yeah. Okay. So we'll look at the data. So what I did is I ran a little analyzer over each repo, and I picked what was the most common indentation this library used, and then I just plotted those as like a histogram. So 84% or 86% of Python repos use 4-space. About 10% use 2-space. So actually, I think some of you were lying when you said you didn't use 2-space. Other is about the remaining 4%. So what is other? Who's like what? 2-space, 4-space? Isn't this it? You can actually find 8 spaces. That exists in the wild, and I don't know how to explain that. Someone's a bit too happy with their tab. That's all I can imagine. And then there's also 1 space. And I don't even think this is executable Python code. It would surprise me if it did run. So another question is, what is the most popular testing library? And for this, again, I just ran an analyzer over all these repos. And I looked for, did you use PyTest, unit test, anything else like that? Or sorry, it was PyTest, unit test, Testify, Nose. Those are the four major ones. Testify is out of Yelp. So looking at this, actually, none was the most common testing library, followed by unit test, Nose. Now I did a quick search, and so none is not a Python library, in fact, just in case you were wondering. So unit test was by far the most common testing library. Nose and PyTest were about equal, and Testify had very few occurrences. So is flat better than nested? If you have your computer open and you open up the Python shell and type import this, you get the Zen of Python, it's called. And one of the lines there is flat is better than nested. So what does that mean? What are we talking about when we say flat is better than nested? What that means is we don't want deep directory structures. We want more flat things. And that way you don't have like these long import statements that are 5 or 6 deep. That's the idea. That's what we want to achieve with the Zen of Python. So what I did is I went through each of these repos again in libraries, and I looked for the maximum import depth. Here's some examples here. So if it's import OS, it's just a depth of 1. If it's import java.utils as utils, that's 2. From scipy.stats, import beta, that's 3. So I ran this analyzer over all the repos, and I took for each repo the maximum import depth. Anyone want to guess what it might be, what the most common might be? Oh, 2s, 3s, okay. It actually is 2, which is terrific. I think that's us obeying this sort of this idiom. It quickly drops after 5, so no one really goes past 5. If there's a few 6s, there's like a couple of 7s and 8s. If there's 1 9, I want to show you this. And so if you have children, cover their eyes. If you have young Pythonistas, cover their eyes. So from com.sun.org.apache.xerces, I think that's how you pronounce it, .eternal.impl.io import malform byte sequence exception. So this is someone writing Java in Python, it looks like. So yeah, what? Functional Python. So I looked for, so Python, as we know, is imperative. But people like to use Python for functional use. I want to know how common that was. So I looked for occurrences of func tools, iter tools, tools, and other common functional libraries inside the repos. And about 15% of us use Python for functional or pseudo-functional operations, which is pretty cool. So there is a minority of us who are actually doing this. So next I want to topic model Python source files. So what is topic modeling? What does that really mean? So let's say I'm Yelp, and I have lots and lots of reviews coming in, and I want to be able to tag those with different topics. So in this case, I have this review. This restaurant had great eggs, pancakes, and coffee. I love their staff. So if I have 3 topics, breakfast, dessert, and cafe, and each topic has associated words, like keywords that sort of fit in there, I can sort of say, yeah, this is about 80% topic 1 and 20% topic 3, and that fits pretty well. But a priori, I don't have these topics. All I have are these thousands and thousands of reviews. So I need to take my data, my raw reviews, and extract these topics. And to do that, I'll use what's called latent Dirichlet allocation, or LDA. So it looks something like this. I pump my reviews into LDA, this machine learning algorithm, and I get output. I don't get the actual topic label. It's not smart enough to give me that this is breakfast. But I get keywords associated with a topic. So probably topic 1 is sauce or sides. Topic 2 is like the breakfast topic. Topic 3 is like a family business, or like who the owner is. That's what the topic is. So that's cool. That's neat. Yelp does that, and they do really cool things with that. Let's apply this to Python files, Python source files. And just to be clear, this is totally backwards and weird. People apply LDA to news articles and reviews and tweets, not to structured Python code or structured code, which has keywords, and developers use weird acronyms and abbreviations for their variables. So I have no idea what I would get out of this. Well, I had some suspicion I'd get like testing files and config files and stuff like that. But I wanted to see what would happen. So did the same thing. Took I think about 100,000 Python files from these repos I scraped, and I pushed them through LDA, and these are the results. So these are the topics that Python developers write about, or we create. So I got Python version, package, author, and this is probably the setup.py topic that came out, which is really cool. It's cool that I could detect that. That was neat. Test equal case tests, that's like the unit test topic, or more generally the testing topic. That's really cool. I found that. I got grid, color, plot, PLT. PLT is short form for like plot and matplotlib. So this is definitely the matplotlib topic. Root, app, project, module, Django config. Okay, so I'm not a Django developer, so I think this is the Django config file. This one's interesting. You have license GNU public, and also license Apache. So above is like the GPL license, below is like the Apache license. We could differentiate between those two. That was neat. Some unfortunate topics are like the date time or the time zone topic. So Python developers have to write about time zones, and that's still something we struggle with. And version dist info. I'm guessing this is the annoying Python, the custom Python packaging topic that we have to write each time. You can see more of the entire list at this URL. Here's just the quick list. I don't expect you to read this, but this is just a nice backdrop. What I found when I was doing this is that Python developers are so unique, and we do so many interesting, diverse things. I'm inside my little data analysis bubble, and I work with pandas and NumPy and Spark or PySpark and stuff like that. But we're writing about all these things. This is like, there's a list of 120 different Python topics that we, as developers, write about. And you might only occupy a small fraction. So it's good to like sort of break out of that. And this was a great opportunity for me to sort of see what the different Python libraries were using that network graph or the results from this analysis. So I sort of want to close on that, and that Python developers are incredibly diverse. We can each do one small part, but Python as a whole can do so much. I think I'd like to end on that. Anyways, thank you.
Cam, thank you very much. That's fascinating. Does anyone have any questions for Cam? And if so, why don't you just, if you could, make your way down to this microphone. Sorry, we can move over to your side. Here we go. We'll bring it over to you. But maybe otherwise, please stand over there or either aisle, and I'll bring this to you, okay?
So you were saying that you were evaluating controversial topics, if I remember correctly, upvotes to downvotes ratio of 0.5, and I was wondering if you actually meant that, and if so, why 0.5? Like, why that number? Or did you mean that to total votes?
I think I meant the latter, to total votes. Sorry,
okay.
Yeah, number of upvotes divided by total votes.
Okay,
yeah.
Cool, because otherwise I'm like, why would 0.5, like why that magic number in terms of ratio?
Right,
but
yeah.
okay, cool.
So I wanted to balance like For each upvote, there's an equal downvote.
Okay,
Yeah.
that makes sense.
Thank
Thanks.
you for clarifying that.
I'll run to you if you want to ask a question. I'll run the mic up.
I can repeat it.
Yeah, sure.
Yeah, make him run. That's funnier.
When you did the LDA, is there like any pre-processing of the data, or just like feed it the files and that it works automatically? I mean, there must be something you have done beforehand, right?
Yeah, thanks for calling me out. So I did do a lot of pre-processing. I use Gensim for this, and Gensim is awesome for LDA. It does a lot of pre-processing already, but I also stripped out Python keywords. So if it was camel case, I made it separate words. If it was underscores, I made it separate words. And that way, because like Python developer, any developer would use very like specific keywords or words, I wanted to break those up. So I did pre-processing there. I removed all punctuation and stuff like that. So I tried to find the most granular words in each one. And I think I extracted or like removed numbers and Unicode figures, stuff like that. Yeah.
Anybody on this side? I'll run to you. Now's your chance. I see a hand. I will take that.
So after you had broken things up in that way, did you have any chance to kind of run those, like see what percentage of things were dealing with time zones or testing and that
good
type
question.
of thing?
I wish I had. I didn't do that. It would have been great to see. I would expect the majority is like sort of Django related stuff and like a very few other ones. I wish I had done that. Maybe an extension would be that. All the code is in that URL that I posted. It's just on GitHub. Pretty easy to extend that stuff.
Another question at the back here?
Yeah, hi. Just a simple question. When it comes to formulating your question, your data question, do you kind of have a set of parameters? Or a set of rules that you follow when you set up your questions?
So I immediately start with like, is the data accessible? Is it easy to find? And often that depends on, can I scrape it or can I like query it? Stack Overflow was a great example where that was just so rich, I could just query that immediately. So given the data is available, the next question is it interesting? Is it more than a simple count? And if not, then okay, next question. And then I also try to find like what is interesting about this data set? What are the cool things? I sort of go from that anecdote to data kind of idea where I'm like, yeah, I'm looking at this data, I see a few occurrences of this. Can I prove that now using the entire data set? Stuff like that. That's kind of the logical step I might take.
Anybody else? Okay, Cam, thank you very much for that talk, and please join me in thanking Cam.
Thank you. Thank you, everyone.